I'm Edith Harbaugh, CEO and co-founder of Lunch Darkly, and I'm here today to talk about engineering over 100 years. And no, that's not a typo, 100 years, and the transformation of development. But first, a little bit about me. Engineering is something I'm very passionate about. I got my Bachelor of Science in Engineering at Harvey Med College, and I was then an engineer at Epicentric and Vignette. And when I was an engineer, I realized I was sometimes very good at building something, and then it would turn out that whatever I built was absolutely the wrong thing. And there is nothing more heartbreaking than an engineer to have maybe, given up some weekends, stayed late, maybe stayed way too late, and built something that when it comes to market, nobody wants. It's one thing where you're like, okay, all those late nights were worth it. It's completely separate if they weren't. So from that, I became a product manager. Yes, I went over to the dark side. And I was a product manager at TripIt and Concur. TripIt, we had millions of users all over the world using our travel app. It was the #1 travel app at the time. And it isn't on the slide, but at Concur, I went even deeper into the dark edge and was marketing. Because I found that you could build something, you could build the right thing, but you also have to tell people about it, which was like this light bulb for me. When I'd been an engineer, I just thought, hey, people will just go read the release notes. It turns out people don't want to do that. From everything I learned from engineering, product, and marketing, I got very passionate about continuous delivery. I'm now the co-host of To Be Continuous, a podcast. And I also started Lunch Darkly as a co-founder. And our mission is, software powers the world. Lunch Darkly powers everyone to deliver and control that software. This is a picture of me in front of the Bay Bridge in San Francisco. I love biking. But let's go back 100 years, or maybe even a little bit longer. So this is somebody I never met, but who I know. This is my great-grandfather, Charles Shearer. So he was born in 1881. And he graduated from 1907 from Purdue with a degree in engineering. So though I never met him, I like to think that, he's part of me. The picture on the right is a bridge that he helped design. It was hailed at the time as a very elegant, classic bridge. The style of engineering that he learned at Purdue to build a bridge was what we would now call very waterfall. If you're building a bridge from scratch, what do? You go out and measure the area. You get all the requirements. Then you spend a lot of time designing it. And designing it in terms of strength, durability, reliability. When I was a college student, there were some classic problems about bridges that had not been designed correctly and they would fall down. So people have been building bridges for thousands of years. There's a lot of kind of case knowledge about how to build them correctly. So he had very rigid phases of measure the area, design it, implement it, verify it, and then maintenance. I say maintenance because no bridge lasts forever without maintenance. The Golden Gate Bridge where I live in the Bay Area, people go out and they just have this constant rotation of people repainting it. All right, so that's what engineering was like in the 1920s. The next engineer is somebody I did know. This is my grandfather, Robert Harbaugh. He was born in 1924, and I loved hearing my grandfather's stories. He had a what you might say is a hard life, but he relished it. So he was born in 1924, and he grew up in the height of the Depression, the youngest of several kids. And he actually dropped out of high school when he was 17. He dropped out to join what was then not even the Air Force, because they didn't have it yet, but the U.S. Army Air Corps. And he'd grown up as a poor kid in Pittsburgh, so to him, this was super exciting. So he told me about one of the first times he flew a plane. So he was in training school in the Army, and he got up in the air, and then he landed it. And he said when he landed it, his instructor, who was in the seat next to him, just started like, giving him the short end of trouble. He's like, Harbaugh, you are one of the worst pilots I've ever seen. And by the way, I see a lot of pilots. Not only are you terrible in the air, when you landed, you couldn't even taxi the plane. How can you not know how to taxi a plane? It's just like driving a car. And my grandfather loved telling the story, by the way. My grandfather said he turned to the flight instructor and said, I grew up in the Depression. I've never driven a car. Ever. I'm doing the best I can. So after this, they moved Granddad over to not be a pilot, but to be the navigator. And as you can see, he lived to be into his 80s, so that was a smart move on their part. Also, I think the instructor after that was like, I'm going to maybe ask people before I go up into the air exactly what their qualifications are. So Granddad Harbaugh loved telling that story because it was basically his version of, I just figure stuff out. Another story he loved telling was after the war, he went to work for AT&T. And one of his jobs was to go to rural areas where there were telephones. So he was basically the telephone installer. Like he had a driver and they would go to a town and he would install their telephone system. And he told another story about how, so he'd gotten his GI Bill engineering degree. So now he was an engineer, but there's still just all this kind of like grind of it. The thing about going to a town to install the telephone system is that you can't telephone ahead to tell them that you're coming. So basically they would go to these little towns that were small enough that they didn't really have a hotel or even existing phone lines and try to find a place for him to stay. So he said once he got to the town and they said, I'm sorry, we don't really allow outsiders here. There's nowhere for you to stay. He said, are you sure? And they said, yes, I'm sorry. We're really not comfortable with a stranger staying in anybody's homes. And my grandfather said, okay, I will go to the next town and put in a telephone system there. And you could wait 5 years for the next cycle of somebody coming through. He said there was just this murmuring in the crowd all of a sudden of, okay, we need to find this guy a place to stay. And all of a sudden, like 5 people are like, actually, I have a spare room. I just have to move some stuff around. So he stayed in that town and he installed their telephone system. So my grandfather, I think, was a very different kind of engineer than my great-grandfather. My grandfather was very much, I'm going to figure it out literally on the fly. I'm going to get in this plane and I'm going to try to, the joke is try to figure out how to fly the plane and land at the same time. I'm going to install a telephone system in a place where there isn't a telephone to tell them I'm coming. And I think there's a lot of parallels to this to continuous delivery. You're always iterating. Like if you wait to go back to the telephone example, if you wait for every town to be ready for you to install that telephone, you're never going to get done. So it's the same with continuous delivery. Continuous delivery is just basically this idea that you don't have to have all of the answers. And I think sometimes continuous delivery gets a bad rap of, well, let's just like blindly drive in a direction without knowing where we're going. It's more, I know I need to go from town to town. I'm going to develop some. I'm going to build some. I'm going to test some. I'm going to deploy. I'm going to release. And it's also that idea of you can just move quickly if you have a faster cycle. So that was kind of the style I think he adopted before there was even the words continuous delivery. Let's fast forward to the 80s. I'm not going to give my mom's age because she would be upset at me. But this is my mom. She has a master's in information systems, and one of her big projects now is she participates in ISO standards. This is actually an ISO standard that she helped guide for systems and software engineering, requirements for managers of information for users of systems, software, and services. She has participated or led multiple standards. Right now, she is involved in even standards for standards. So her style, I think, is more like my great-grandfather. It's very much, helping people decide the requirements, get together design for how they should build software, implement, verify, and then go into maintenance. But what's really interesting is one of the standards that my mom works on is even around how to get better at software. Like there's just, I think, this passion in our family for how do we become better and better and better engineers? And how do we empower other people to do that? So then there's me. I started working about 20 years ago, and I would say that was the heyday of Waterfall. I remember literally as a young analyst, you would have this long phase of a PRD, a products requirement document, that would then get transferred into a functional requirement spec, which was a functional, which FRS, which is like detailed use cases, sequence diagrams, and then we would actually have to do a physical sign-off. I remember I would walk from desk to desk of the office trying to get the product manager and to sign off that, yes, they agreed with the specification. And then it would go into development and then ship. The flaw in this, which I saw, was no matter how hard I tried to write more use cases, no matter how hard you tried to just nail everything down in that specification phase, things would always come up. There would be something when you went to the UI phase that's just like, oh, we didn't really think about that when we just had the use case, but how does this actually work? And then there's actually the phase even after that, when you went out into the real world. And I put this of all the hopes and dreams of the product manager and the engineering team colliding violently sometimes with the wants and actual desires of actual users. So for a while, there was this idea that you could just spend more time in specification. Okay, people didn't understand what we had built. Let's spend, instead of 3 weeks in specification, spend 3 months, 3 years. So you started to see these extremely bloated releases. Probably the classic example of this was where Windows got to, where they had releases that everybody knew were bad, but they still had to ship them because they had just gotten their own weight. This all just started to break down and crumble, which is how we got to continuous delivery. Instead of having a 3-year release, which is just basically saying, hey, I'm going to go off on this journey, and in 3 years, I'm going to get this perfect, wonderful bridge. Let's have smaller and smaller and smaller and smaller releases so that we can continually deliver value, which is where we are today with modern application delivery. You heard earlier talks about how to just deploy quickly, move faster, and get value to actual users sooner. So much time in engineering can be spent on arguments. Will somebody like this? Should they like it? What's it going to be like in the real world? The answer is always, let's try it. Let's get it out into the real world. Let's have people see what this is like, whether it be through a canary release, a dark launch, a beta program, and then quickly iterate. Just see how it works in the real world. The knock on continuous delivery has always been, though, well, what if it doesn't work? Facebook seemed to have this luxury that they could ship bad features, but I'm not Facebook. Facebook's ace up their sleeve has always been the ability to turn features on and off very quickly. They have an internal product they call Gatekeeper, where they have the ability to ship something and then kill it if it doesn't work. So in many ways, they have the best of both worlds. I talked earlier about bridges. This is, again, the Bay Bridge that connects Oakland and San Francisco. I think the Golden Gate Bridge gets a little bit more hype. I don't know whether it's the orange color, but the Bay Bridge is one of my favorite bridges. And about 10 years ago, the Bay Bridge had a big problem. Though it had been built to stand for over 100 years, after the 1989 earthquake, the upper deck collapsed. They reinforced it, but they knew that it wasn't really sound, that if another big earthquake hit, the bridge would not withstand it potentially. This was a real classic engineering problem. You have a bridge that isn't going to survive, but you don't have the luxury of just tearing it down and building a new one. Hundreds of thousands of commuters and people going to doctor's appointments, students, just everybody depends on this bridge. This might sound like a software project that you have. If you have some sort of legacy code, the dream is always like, well, let's just destroy this and start over. You can't usually do that. If you're a bank who's running payroll, you can't say, I'm just going to build a payroll system from scratch. Ignore this old payroll system. So what we did in the Bay Area was we built a new bridge, a parallel bridge. So you can see here, there's the old bridge, and they literally had a new bridge built and then set it up side by side with the old bridge so that they could continue to have traffic going over the old bridge while they assembled a new one and made sure that it worked correctly. To go back to 100 years of engineering, this is, again, trying to say, hey, we can't depend on the past all the time. On the other hand, we have to be careful and build something carefully and slowly. I am almost at the end of my talk, so I'd like to take this brief moment to say if you have questions, I would love to hear them. And then get back from bridges to software. The reason why I love that picture of the bridge was I think it's just something that software engineers can adapt in their own application. If you have a mindset of continuous delivery and being able to deploy whenever you want, and then separate out that to release when your customer is ready. If you can have a parallel path ready and then switch over traffic gradually, it's much safer. If you have the ability to, for example, say, hey, people who are in Australia, try this feature before New Zealand, you just get a lot of relief for that. So I hope the takeaways you've had from this talk are there's no one right way to build software. If you try to build a bridge by just saying, hey, let's just start throwing some sand on the ground until it all sticks into one pile, it's not going to work. You have to have some framework of how do we want to build this bridge and how should it move forward. So to say this, I think this false straw man of we don't need any requirements, let's just start throwing features out there. I don't believe that. You need to have some sort of thesis. You need to have some sort of product management framework. You do need to have some sort of requirements phase. However, if you could shorten them and make them very quick so that you can react, you are able to move much more quickly. So thank you. And PJ,